So let's consider one more example on work on energy. And what we have here is that we have this mass 2 kilograms, and right now it's moving with the velocity 40 meters per second, and this is a smooth surface, but from here to here there's friction, and this guy keeps moving and encounters the frictional part, and it goes through the friction and then it climbs an incline. And the question is, what is the height this mass is going to climb? So it starts with the kinetic energy, it loses some energy because of friction here, and then in the end all it has is potential energy. So it's basically work energy problem. So let's start. First of all, how much is the energy it starts with? The initial kinetic energy we all know is half mv squared, which is half multiplied by 2 multiplied by 40 squared, and that gives us 1600 joule. Okay, and how much energy it loses to friction? And first of all, how much work friction does on the object? Well, the work done by friction is always negative, so it always takes up energy. We already have talked about that, but let's do it again. We know that if the guy is moving like this, if this object is moving like that, friction acts in the opposite direction, Fr. And from free body diagram we know, as it's not moving on the y-axis, N is mg, and Fr is mu n, which is nothing but 0.1 multiplied by 2 multiplied by 10. Let's take g to be 10 meters per second square, and that gives us 2 newtons. So that is the force, and we know that work done by any force is given as F times d is the distance for which the force acts, multiplied by the cosine of theta, which is the angle between F and d. F here is the force of friction that is acting on the mass, is 2 Newton, times d is the distance traveled, which is 4, times cosine theta. Well, you see the object is traveling in this direction, but the force is in this direction, so theta is 180 degrees, and that gives a negative sign. So cos of 180 degrees, and that gives us 4 to the 8 joules. Okay, in fact minus 8 joules. So we start with 1600, but we lose 8, and that gives us 15,092 joules. Now how high does it climb? Well, this is the energy, or the kinetic energy, this guy has right here after it has crossed the frictional part, and whatever energy it has will go in increasing the potential energy of the mass on the cost of losing the kinetic energy. So here it has kinetic energy, but it loses kinetic energy, it climbs up, and somewhere here it loses all its kinetic energy, and all the kinetic energy is converted to the potential energy. And how, and what is the expression for potential energy? Well, it's given as mgh, which should be same as 1592. So 2 multiplied by 10 multiplied by h equals 1592, and h turns out to be, well, it turns out to be 796, so 79.6 meters. Well, that's a lot of distance, but in problems we can do anything. I hope it's clear.